Okay, in this topic we'll be summing up the laws of indices. So let me just go over the laws of indices. So at this point you should have on a note or on the side laws of indices. And my advice, try get an index card. Right, so keep track of your equations. So let me zoom in a little bit more so it becomes a little bit more bigger and visible. Okay, now let's start by using an example. 2 to the power of 5. Right, first of all we need to know what is what. This 5 here is the index. This 2 here is the base. Okay, so 2 is the base and 5 in the index. Now remember, we are dealing with indices for this time. So this could be expressed just to say times 2 times 2 times 2 times 2. Okay, and how much is that? That's 4, 8, 16, 32. So 2 to the 5th power is actually 32. That simply means 2 times 2 times 2 times 2, etc. So once we have this, let's go and recall the rules. Rule 1. Now when I call rule 1, rule 2, rule 3 and rule 4, I don't expect no one to remember them as that to be rule 1. It is just a rule. Alright, so the reason why am I calling it rule 1, rule 2, rule 3 is just to identify that that's 1, 2, 3, 4, 5, 6, 7, etc. But it's not to say that you must remember that this specific rule is rule 1. Alright, it could be you could call it rule 7, rule 6. It's up to you. The whole idea, it is a rule. Okay, so now the first main rule here in indices is that a base as x to the 0 power is always equals to 1. So anything to the 0 power is 1, whether this base here is in brackets and raised to a 0 power, whether this is a negative value raised to a 0 power, with the exception, there's one exception to this rule, except for 0. Okay, except for 0. For example, if you have 0 raised to 0, that is not equal to 1. That's the only exception. Okay, so then another rule is a base to a negative exponent equals 1 over that base to the positive exponent. Okay, now this is what we did. The minus power simply means to bring it to the bottom, means division. Alright, so I'm just breaking it up to its simplest. Then we have rule 3, another rule. Okay, and this other rule here is a base x to the power of m times x to the power of n. I could have used here a. I prefer to use x this time, so that is okay. So therefore, once both of them are the same base, we will keep the bases and simply add their indices. Okay, so now let's go with another rule. Call this rule 4. Remember, you don't have to memorize it in that order. So let me give an example for this one here. An example for this one here will be, say for example, we have 3 to the 3rd power times 3 to the 5th power. Okay, that will give us 3 plus 5, which is then 3 to the 7th power and to the 8th power in indices form. Right, this is in index form, not a standard form. Right, this is a bit better because almost finishing ink. Right, and so we go to our next rule. Since we are dealing with multiplication here, let's deal with division. If you have a base to a power divided by that same base but to a different power, then we will keep the base and simply subtract the denominator power denominator power from the numerator power. That is what this means. So let me use another example. If I have 3, and I'm going to use the same top one here, 3 to the third power divided by 3 to the fifth power. That now is going to give me, okay, I'm going to have 3 minus 5, which then gives me 3 to a negative 2. Alright, but recall this rule here as rule 1 that says that if you end up with a positive base and a negative power, then you simply convert it to 1 over 3 to the positive power. If asked to state your solution in index form as a positive power, this would be correct, this would be wrong. Okay, another rule that follows is, and we have a base to a power raised to another power. That gives us now to keep the base and simply multiply their powers. That's all that what that is saying. Okay, so let's see an example. 2 to the fifth power raised to the third power. This is simply telling us keep the 2, but now multiply 5 times 3, which is then 15. Okay, and that's our solution. Now mind you, they don't have to be positive. They don't have to be positive or whole numbers. They can be negative and they can be fractions or decimals. Just follow the rules. If it's their fractions and you're multiplying fractions, you know what to do. If you're adding or subtracting fractions, you know what to do, especially if they have like denominators or unlike denominators. Okay, so now we're going to what you call a rule 6 now. And this rule says that if you have a base to a fraction power n over m, okay, to a fraction power, that could be written by saying the root of x, and you put the value, which is the top value of the fraction, inside and the m outside. Okay, so then what does that mean? Let's see an example for this one here. I'm going to use red for that one. So if I have 2 to the, let's say 3/5, just for rearranging in radical form, this can then be written as the 2 to the third power and the fifth root of it, and that's it, expressing in that form. Now we're going to get a little bit more advanced, a little bit more complicated. This was to a fraction power, so you could write it this way. Our next way of writing this, and the beauty is because it's multiplication division, this could be written as to say x to the m root, and this value of n we can go outside, so you could find the root of it first and then raise it to that power. Now remember, this is to a positive power, so if I have now, say, call this rule 6, and rule 7, I'm going to be using red pen now. If I have a base to a negative fraction power, what is that? Well, it's no more different than what you have been doing. We all know that so long as you have a base to a negative power, you will put 1 over that base to a positive power. Likewise you will do here, except now that the power or the index in this case is a fraction. So you're going to do this. You're going to put here 1 over a to the n over m power. That's it. But you already know that if you have this information, you could reverse it and use this method. So let's use, and that's the reason why I'm using different letters compared to this. So if you have a to the nm power, you could write it out this way or this way. So our next way to write this out is to put 1 over the root of a m and raise that to the n power. Okay, but you must put that division sign there. Okay, so we're going to be trying some examples now. So let me keep this rule on the side and let us do some working here. So if I have now a to the 4th power times a to the 1/5 power, what should I do? Well, I want you to write on the side, this tells me that if the bases are the same and their powers is different, you simply keep the base and add their indices. Okay, so that's all you need to do. Likewise, you will do here. You will simply say, since both of them are a, you keep the a and you will say 4 plus 1/5, and that now gives me a 4 1/5, or you can write it as an improper fraction, a, which is 21 over 5. So either value is still correct. All right, so now we go to our next one. Consider that you have e, and that's just a letter. In maths, you will get to understand that this is very, very important. It's a particular value, but for right now, it is just a letter for us. All right, so let me just write this: -6 divided by e to the 8th power equals. Well, according to our rule, it states that if you have the bases which are the same, okay, and you are subdividing them with different powers or indexes, then you will keep the base and simply subtract their powers. But you must be careful with the negative sign with the second one. All right, sometimes they may be negative, so you apply the rule. This is the rule, so you put here now e -6 minus 8, and then that will give us e to the -14, and that's your solution. Given that they did not tell you to state your answer as a positive index or negative index, so this is correct. But if they had told you to state it as a positive index, then this would be incomplete, and so you will need to go back and recall another rule, which is here now. This rule, that if you have a base to a negative power, then you can convert it this way. Therefore, this would then be 1 over e to the 14th. This would be another rule that says a base to a negative power equals 1 over that base to the positive power. Okay, now because on your assignment I am asking that you state one of the laws, you just do this or do this. Once you state one rule used in that problem, then that is okay. You don't have to state every single one of them, because some of them you may apply differently. All right, so you may apply a different rule compared to a specific one. Let's go to a third one. This third one states, okay, 2x to the 3rd raised to the 4th power. Okay, now in this case, what you need to do is break them apart. We'll take the 2 and raise it to the 4th power, because everything is inside of the bracket. So you put here 2 to the 4th power, and then you put x to the 3rd to the 4th power. Okay, you may put this in bracket, and I would encourage you that you use brackets, because this could have been negative. All right, so here you have 2 to the 4th power, which is 16, and then here, you know, the rule says a base to a power raised to the next power will keep the base and simply multiply their powers. So this gives us now x3 times 4, which is then 16x to the 12th power, and that's our solution. If these were negative, just simply multiply them with their signs. Okay, it is very straightforward in that case. Okay, so we're going to the next one now. A fourth example. Consider that we have 2a to the 3rd power raised to the -4th power. Okay, this is a base to a negative power. This states that if you have a base to a negative power, that becomes 1 over that base to the positive power. Okay, so what you do here is that you put now 1 over 2a third to the fourth power. You apply now this one from before, the same way how you work this out to get the answer. So when we work this out, this is the working which would have occurred. So let's just write that information down here, and that would give us 1 over 16x to the 12, and that would be our solution for that particular problem there. Okay, now we're going to a problem where we have a little more challenge. Fifth problem. Consider that you have a to the 8th power divided by a to the 3rd power, everything raised to the 1/5 power. Okay, how do we work that out? Well, we call PEMDAS. PEMDAS says parentheses first, so we must go inside of the parentheses. Once we are doing parentheses, we apply again the rule of PEMDAS. Okay, so this is telling me now, according to this rule, this piece here is telling me to use this rule here. So I must put on this side a base to a power divided by that same base to a different power. We'll keep the base and simply subtract their powers. This now gives me a 8 minus 3 to the 1/5 power. Okay, this now gives me a 8 minus 3 gives me 5 to the 1/5 power. And now we can recall here this other law. So this is the law that we will be using, which is a base raised to a power raised to another power. We'll keep the base and simply multiply their powers. So we multiply their powers here. We say 5 times 1/5. The 5s will cancel out, giving me a to the first, or simply a, and those two would be correct. Alright, not all the times you will be getting as a positive value. Sometimes they may become a fractional value or a negative value. It depends on the problem. Now we are going to some other problems, and these problems start to become more challenging. We are at problem number 5. We're going to problem number 6. Right, and in problem number 6 we have a situation as follows. Consider that we have here 25 over 16 a to the 4th and b to the 2nd over bracket to the 1/2 power. Now how do I solve this? Well, there are various methods you could solve this one here. Okay, so what you will do is that you will break them up into its components. So this is what you do. Equals. You will take this 25 and raise it to the 1/2 power, 16 to the 1/2 power. So you put 25 raised to the 1/2 power, a to the 4th raised to the 1/2 power over 16 to the 1/2 power and b squared to the 1/2 power. Everyone will be raised to its 1/2 power. Now convert 25 to a base, which gives me 5 squared to the 1/2 power, a to the 4th to the 1/2 power over 16, which is 4 squared to the 1/2 power, b squared to the 1/2 power. Alright, now the rule says that if you have a base to a power raised to a next power, we'll keep the base and simply multiply their powers. So that's what we are going to do here. So we keep the base 5 and we multiply 2 times 1/2, which gives me 1 over a 4 times 1/2, which is 2, then 4 here, 2 times 1/2, which is 1, and then b 2 times 1/2, which is 1. This is equal to 5a squared over 4b to the 1st, and that's your solution for that particular problem there. So in other words, these problems are not difficult, just you need to take them piece by piece. Okay, let's go to another problem. Problem number 7. Okay, a to the 1/5 divided by a to the 1/4. Okay, so how do we work this out? Well, according to the rule, it says that so long as the bases are the same, which is this one here, and you are dividing, you will subtract their powers, but you keep the base. So we will be using this rule here, and this is what I want you guys to write on the side. So here you're going to put now a base to a power divided by that same different power. We'll keep the base and subtract their powers. That's the rule. This is what I want you guys to write on the side. This is then a 1/5 take away 1/4. Now because this can get very messy in working, you may decide to do the working here on the side and put 1/5 take away 1/4. You find the LCM, which is 20, and 20 divided by 5, which is 4 times 1 4. 20 divided by 5 by 4, which is 5 times 1 5. This now gives me negative 1 over 20. So therefore this is equal to negative 1 over 20. Now this is the first rule you use here. This is our next problem. We are not to leave our problem this way unless they tell you. So our next way to write this up as a positive index is that we can recall now this law here that says a base to a negative power is equal to 1 over that base to a positive power. So we do that. We now give this to be a, we put 1 over 20, and that's our solution. Okay, so we're going to another problem now. 8. Consider that you have now say just a value. Consider 3 to the 4th power times 1 over 3 third root of 4 times 3 to a negative 1/2. Okay, the way you're going to work this out is that you need to convert all of them to have the same values. Okay, now let me put here a 3, the 4th root of 3. I'm going to put the 4th root of 3. All right, so all of them actually do have the same bases. It's just you need to convert them for them to look alike. So what you do here, you come to your first step and you're going to write now this 3 to the 4th here, and then you recall this rule, which is this one here. I convert it to this form so they are all in alignment. So this is telling me now that this is equals, you put your times, let me use the times sign here. I put that 3, and because it's a 4th root, it's to the 1/4 below 1, well, it needs to be negative, just to a negative 1/4 power times 3 to a negative 1/2 power. Now what rule do we see here? The rule that we see there is this one here. A base to a power times that base to a different power will keep the base and simply add their powers. This is only an example of 2, but it can also work for 3. The concept is still the same. So you're going to write here on the side a base to a power times that base to a different power will keep the base and simply add their powers. So this is what you do here. You keep the 3 and we'll say 4 plus a negative 1/4 plus a negative 1/2, because that's what the rule says. So this is plus 1/4 plus 1/2. You keep the base, and when you add this up, you end up with 4 plus negative 3/4. Alright, so then you add the 4 plus the negative 3/4. Well, you put on the side 4 plus the negative 3/4 on the side. You can borrow 1 from the 4, and this becomes 3. 4 over 4 plus negative 3/4. So now there's no whole number on this one, so you can bring down the 3. 4, both of them are the same denominator. You keep the 4, and you say 4 take away 3, which is 1. So the answer here will then be 3 to the 3¼ or 3/13/4. Just change this to an improper fraction. Okay, that's problem number 8. So this is how you will work this out, by just following this rule. Remember, you must remember the rules for adding fractions and whole numbers. So all this will be coming into play here. Let's go to another one. So we have now say we have here a to the 4th over the 3rd root of 8 a. Okay, so the way you're going to work this out again, you break this up apart. You're going to do this: a to the 4th, I put the 3rd root of 8 and the 3rd root of a. Okay, now once you have done this, remember that the 3rd root of 8 is actually, okay, come down here again, sorry about that. We have the problem here, so we separate them. All right, so then you do this: you put a to the 4th over, well, 8 is actually what? You can put that on the side here if you want. This is actually 2 to the 3rd to the 1/3, because 8 is actually to the 3rd power, and the 3rd root is actually to the 1/3, and then at the bottom you have a to the 1/3 power. Okay, this now gives me a at the top to the 4th over, and this cancel out, giving me 2. We still have a to the 1/3. So what do we need to do here? Well, because this is division, we'll keep the base and subtract this bottom power from the top power. But just remember, a while ago we did something like that, where we had 4 and 1/3. Okay, so we will be subtracting that out. So this now gives me a to the 4 minus 1/3 over 2. Now borrow 1 from the 4, and this gives me a 3 and 3 over 3 minus 1/3 over 2, which is equals a 3/2 over 2, or a 11/3 over 2.